Hello, I'm Rohan from Pondicherry Institute of Medical Sciences, and today I'll be demonstrating for you lung functions. For that, I'll be using this little gadget of mine. So what I've done is, I've taken a plastic bottle, cut it in half, placed half a balloon as a diaphragm, and using this little balloon inside as the lung. So first let me blow this balloon up. So now what I've done is, I've expelled the air inside the bottle to create a negative pressure, and I've sealed the vent. So as you can see, this balloon is open, but it still remains inflated. That's because of the negative pressure inside the bottle, here. This is similar to the lung, where the negative pressure inside our thorax maintains the lung in inflation. As the negative pressure inside the lung increases, as when I pull this diaphragm down, the lung will expand as seen. You can see the balloon expanding. Now, if you take a clinical condition such as pneumothorax, where there's a puncture to the thoracic wall, there's a loss of this negative pressure and the lung collapses as such. Now I'll demonstrate two types of lung disease, namely obstructive lung disease and restrictive lung disease. Before we start, let's introduce two terms, namely forced expiratory volume and forced vital capacity. Now, if you look at this graph of volume versus time, you can see that forced expiratory volume is the volume of air that can be forcefully expelled in 1 second by a person. Forced vital capacity is the maximum volume of air that can be expelled on forceful expiration. Now, for restrictive lung disease, I've used a thicker balloon than the previous model. As you can see, the same negative pressure inside the thoracic cavity is not able to keep this lung inflated as much. This is similar to a fibrous lung in restrictive lung disease. And as you can see, the lung does not expand as much when the negative pressure increases. Thus, you can see in a restrictive lung disease, the functional vital capacity, as is seen by this graph over here, is reduced. Similarly, the forced expiratory volume in the first second is also reduced. Obstructive lung disease, I've used the same model here with a cap with a hole in it to represent the stenosed airway in obstructive lung disease. As you can see, the lung is still expanded as much as it was originally. Thus, there is no decrease in the functional vital capacity in an obstructive lung disease. However, as you can see here, because of the stenosed airway, air takes longer to exit the lung. So because of that, the forced expiratory volume in the first second is decreased in an obstructive lung disease, as is seen by the red line, whereas the forced vital capacity remains the same.